students. See the next one from 11th standard, motion in a straight line chapter, Ncert exercise problem number 3.12. Okay. See the question. Listen. It is one fantastic problem. We have to approach in different way this question. After the end of the question, we have to learn how the losses of energy happen when the ball is hit the ground. Okay. So, for example, let us take I take one ball. Either I throw the ball or I leave the ball towards the ground. So, after hit the ground, the ball is rebounds back. For example, if I leave from the ball, for example 1 meter height, again it will not come exactly 1 meter height. Maybe, depends upon this material. It is about half meter height. Again it will hit the ground, maybe 1/4 height. So like that, the ball will hit the ground, again hit the ground, stop. Okay. So how the velocity is reducing for each collision with the ground? Okay, like that kind of question. Okay. So some interesting thoughts will be creating on your mind. Okay, so we discuss this question. Please see the question. Listen. A ball is dropped from a height of 90 meter. Let us imagine 90 meter to height. This is 1 meter. This is 1 meter. Like this 90 times. Okay. A ball is dropped from a height of 90 meter on a floor. With each collision with the floor, the ball loses 1/10 of its speed. Very important point. So whenever to hit the ground, it loses its speed. What is that? 1/10. 1/10 of speed is reducing or losing. That means 10% is losing. 90% speed is available. Okay. If for example 100, when we hit the ground is 100, after that 90 is there, like that. Okay. In this situation, plot the speed and time graph of its motion between t is equal to 0 second to z equal to 12 second. Say for example, maybe that material highly elastic means, so it is frequently it is hitting ground, like that is continuously collision with the ground. But some time duration they mention up to 12 second. Okay, up to 12 second. Okay, so initially it is hit the ground, it's lost its speed, again hit the ground, again rebounds back, hit the ground, again lost the speed, rebounds back, hit the ground, again lost its speed. So like that is happen up to 12 second. So you should compare the speed and time in this situation, how the graph will draw. That is the question. Okay. So the graph is secondary. First you should understand the concept and derive the question within up to 12 seconds. How the velocity is changing. So we discuss. See that. Now this is the ball. The ball is hit the ground. Okay. The height is what? 90 meter height. While we leave the ball at a particular height, initial velocity is 0. So no need to push, just leave the ball. So initial velocity is 0. So initial velocity is 0 meter per second. Then this ball is allowed to move under the action of gravity. So the gravity or acceleration is 9.8 meter per second square. Okay. Then height covered. See that how much height? 90 meter. Height is 90 meter. Then what is the velocity to hit the ground? What is the velocity to hit the ground? அப்போ இது தரையில் போய் மோதக்குள்ள இதோட ஸ்பீட் என்னன்னு நம்ம பார்க்கணும். அதுக்கப்புறம் தான் அதிலிருந்து 10% லாஸ். ஓகே. So final velocity you should find. As well as they are asking speed and time graph. So you should calculate the time also. So what about the time taken to reach the ground? This is our first area. So we find first that one. See that. First one. Okay. This is the first one. We are going to find there is a time factor. What about the time to reach the ground? Okay. So you know the relationship between the position and the time from the equations of motion. Can you remember? Yes. That is S is equal to ut plus at square. So by using this equation, it is possible to find the time taken by the ball to hit the ground. That is taken as t. Therefore, S equal to ut plus half at square. Initial velocity 0. So this term becomes 0. So S is nothing but there is distance covered, that is height, is equal to 1 by 2. Acceleration is nothing but towards the gravity. So that is g, then t square. Therefore t square equal to 2h divided by g. Therefore t is equal to square root. So whole root of 2h divided by g. So whole root of 2 into, what about the height value? Height value is 90 divided by g value 9.8. Therefore t is equal to whole root of, so 2 into 90, that is 180. 180 divided by 10 means 18 will come. Divided by 9.8 means that is 18.38 will come. So you should take, if it is difficult to calculate means you take log also. Okay, so 18.38. So if you take this root, we can get 4.29 seconds. So in 4.29 seconds, it is covered 90 meter distance. And we leave the object at 90 meter height. So 1, 2, 3, 4, 10.29. Okay, so 4.29 seconds, it will cover 20 meter height. Now this time value is over. Okay, then one more thing, if you observe the question, each collision with the floor, the ball loses 1/10 of speed. Whenever to collide with the floor, the ground, it lost its speed. It lost its previous speed. So now you should know what is the speed while hit the ground first. Upper last division. So while we hit the ground, what is the speed? After rebounds, its speed is lost. That is 1/10 the speed is lost. First, while hit the ground, what is the speed? So that is v. That is final velocity like that. In this case, it is a final velocity. So we find, see that. So final velocity of the ball, that is, you know the equation v is equal to u plus at. So you know initial velocity is 0, so u will not come. So v is equal to gt. The acceleration equal to gravity. So v is equal to gt. Therefore v is equal to g value 9.8 into t. T value what? 4.29. So approximately, not approximately, 9.8 into 4.29, we can write 42.04 meter per second. So here value what? 42.04 meter per second. So while it is hit the ground, the speed of the ball is 42.04 meter. Okay. Now the ball is first time to hit the ground. After that, what happened? It is rebounds back. When it is rebounds, what is happened? It's lost 1/10 of speed. 1/10 of speed. 1/10 of speed means what is the meaning? 1 divided by 10th of speed is lost. Add 1 0, that means what? 10 divided by 100, 10% is lost. That is the meaning. Okay, 10% is lost. What about the remaining percent? 90% is working. That is the meaning. Here, 10% is lost means 90% is working. Okay? So, I can write, so this speed is converted into 90% only, not 100%. When it is rebounds back. See that now the ball is hit the ground. The same diagram is a little bit confused. So I draw here. Okay. So now it is rebounds back. For rebounds back, that initial velocity is, that is UR, that is rebounds velocity. Then to reach maximum height, velocity is 0. Then taking time to upward direction or taking time to maximum height, that is T dash. Clear? Okay. So I hope this is already over. This is also over. Now what you are going to find? Rebounds velocity. Rebounds velocity, that is only 90% of initial velocity. So 90% is nothing but 90 divided by 100 or 9 by 10. So 9 by 10 of previous velocity. Previous velocity what? 42.04. See that 42.04. So 9 by 10 into 42.04. Okay. So 42.04 divided by 10, I can write 4.204. Then into 9, that is 37.84 meter per second. So here what is the velocity? 37.84 meter per second. Understand? Now see that 10% of speed is reducing, only 90% is there. Then what about the time? You know already, to hit the ground, you found the time, 4.29. Like that, what about the time to reach the maximum height here? Okay, that is time of ascending. Okay, so please listen. So that time of ascending, so already we use T. So for simple idea, I taken as T dash. See that the time taken by the ball to reach maximum height, the second case, that is T dash. So as usual, V is equal to U plus AT like that. V is equal to UR, that is rebounds velocity, plus AT dash. So in this question, final velocity here is 0. So V is 0 equal to UR. It is opposite to the gravity. See that acceleration is equal to minus G because it is opposite direction to the gravity. So A is equal to minus G. So now minus GT dash coming this side, GT dash is equal to UR. Therefore T dash is equal to UR divided by G. What about U? U is nothing but 37.84 divided by 9.8 G value. So we can get 3.86 second. So in 3.86 second, it is reached the maximum height. Okay? Understand? Here what about the time? 4.29 second. After that, what about the time to reach maximum height? 3.86 time. Okay? From 90 meter, what about the time? 4.29. After hit the ground, now what is the time? Yes, 3.86. So this is time of ascending. After that, what will happen? Again to reach the ground. So please students, you should know very well, time of ascending is equal to time of descending. அப்ப டைம் மேல போற டைமும் கீழே வர டைமும் ஒண்ணுதான். Understand? So the next, see that the okay. So please keep an idea. So time of ascending is equal to time of descending. Okay, right. Now after reach the maximum height, again to hit the ground. Okay, while hit the ground, what happened? I mean, for second time rebounds back, you know, for second time rebounds back. Okay, first time rebounds, its velocity reduced as 37.84. Again next rebounds back, its velocity reduced again 10 times. What is that? 10% is reduced. So I can write second time, you know. Okay, so first time is just UR, small UR. Next time I didn't draw the diagram, that is capital UR. So I can write 9 by 10 of initial speed. Initial speed what? Initial speed is what? UR, small UR. Capital UR is next. See that this is the next diagram. This is capital UR. Now capital UR only is going. Capital UR is nothing but what? 90% of small UR. So please note, capital UR is equal to 9 by 10 of small UR. So 9 by 10 of small UR what? 37.84. So I can write 34.05. So here 34.05 meter per second. Okay. So now you got some speed. What are the speed you got? That one is like to reach the ground 42.04. Again rebounds back, that is 37.84. Again next rebounds back, that is 34.05. Clear? Then what about the time? First to reach the ground, what is the time? 4.29 seconds. Again rebounds back, what is the time? 3.86. That is time of ascending. The time of ascending is equal to time of descending. Okay, please I will say one more time. First from 90 meter to reach the ground, that is 4.29. Again rebounds back, that is 3.86. Again to hit the ground, that is time of descending, that is also 3.86. Okay, now what is the total time? The total time you must add, we can get 12.01 second. Again no need to calculate one more time to go into hit the ground, because what is the condition? Up to 12 seconds enough. So this is 12.01, not that much different, 12 seconds low. Okay, so now we got the different types of velocity. Initial value 42.04 or initially 0, then 42.80, 42.04, again 10% is reduced, 37.84, again 10% is reduced, 34.05 up to 12 seconds. Okay, now you got speed value, now you know the time period. So it is possible to find speed time graph. Shall we draw that? Okay, wait. Now see the graphical diagram. Okay, in x-axis let's take time factor, in y-axis I'll take speed. Okay, listen, first you understand this data. Okay, first I leave the ball at particular height to reach the ground in how many seconds? 4.29 seconds. What is the velocity to reach the ground? 42.04 meter per second. After that, at the same moment, because at the same time it is moving upward direction. at the same time with 90% velocity. So the same time with 90% of 90% of this velocity, 37.84 meter per second. Okay. Then after reaching this position, okay, so here the speed is 0. So here the speed is 0. So up to here 4.29 second. Then up to here, what is it? 3.86 second. So that two values you can, we can get 8.5 second. Okay, again it is time of ascending to hit the ground. The same time 3.86 you should add, we can get 12.01. So from the speed again 90% is reducing. Okay, that is 34.05. Okay, so this is the data. Okay, so from this data, now I am going to draw the graphical diagram. See that 4.29, 42.04. Approximately in x-axis 444, y-axis also 444. Listen, I put one like a symbol here. That means the starting value origin is 0, so 44 increasing, but in between up to minimum reading is what? 34 only. So I will take from 32. Okay, so the remaining number is this height in the graph. So that is indicated by the symbol. Okay. So now 32, 36, 40 like that. So first reading 4.29, 42.04. Approximately 4.29, 42 here. So from 0 to we started. Okay. After that the same time 37.84. 37.84 approximately here. That round here. So I will join here. Okay. So this both time factor 4.29. 4.29 approximately. Then after that 8.01 second, speed is 0. Speed is 0. So I join here. After that 12.01 approximately here, 34.05. 34.05. So here, so okay, the ball here over there. Then velocity reducing. Then velocity reducing, then reach 0. Then again velocity is increasing. Understand? Listen. I leave the ball. Velocity is increasing. Okay. At the same time. Okay. At the same time, the velocity is 10% is reducing. Then while reaching the maximum height, speed is 0. Then again increasing the speed. That's all. So this is the graph we can draw from given situation. It is a very, very important question. We can get clear idea from how to draw the speed time graph with this kind of situation. Okay? Okay students, I hope you understand this question. Okay? So 1 or 2 times you observe this video, then only you can understand well, I hope. Okay?